So, willkommen. Wir wollen keine Minute verschwenden von der kostbaren Zeit von unserem ESA-Generaldirektor Josef Aschbacher. Es ist eine große Ehre, dass er hier bei uns ist an der TU Wien. Herzlichen Dank fürs Kommen. I'm sorry, I have to switch to English. So I'm very happy and very honored that we have Josef Aschbacher here, Director General of ESA. Yesterday we had a wonderful talk about a successful one-of-a-kind experiment of metal printing from Makaya at ESA. Today we're looking forward to hearing more about the strategies, the future ideas, and how we at TU Wien, the researchers, or we in Austria, the researchers and students can go further with our space projects. Thank you very much. Welcome.
So thank you. Very happy to be here. My name is, as you know, Josef Aschbacher. I'm the Director General of the European Space Agency, and I happen to be Austrian, so it is my home country, and it's always nice to come back here to my home country. It's actually quite unusual that the Director General of ESA is an Austrian or is coming from a small country. Usually they come from Germany, France, Italy, at least for the last 50 years, so it's a bit of an exception. So I'm particularly happy to be here with you and talk about space. So what do we do? I've put a few slides together, but I understand it's half an hour talk and then a bit of Q&A. I'm also very glad to see Wolfgang Wagner here, Decan of the university, one of my old friends and colleagues. We have worked together a lot. Really happy to see you a bit in an unusual seat in the midst of students, but thank you, Wolfgang, for joining as well. So what do we do in ESA? Let me just show one slide with a few facts and figures, what ESA is like, what we are doing, how big we are, how many member states we have. So you see it all on the slide. This is on one sheet put together some of the key facts. We have 23 member states. Sometimes people confuse us or think we are part of the European Union. We are a different organization. We call it an intergovernmental organization. That means the governments of ESA, you see the flags here, have joined, they are members, and they are running us. That means they are our stakeholders and our interlocutors in terms of governance of ESA. Of course, we work a lot with the European Commission. About 24% of my budget, or 1/4 of my budget, comes from Brussels, from the European Commission, on a bilateral agreement which we have in order to develop space infrastructure for them and with them. But we have about 6,000 people working in ESA. Actually, we have a very small office also here, or it's not an ESA. We have a small office as ESA, which is dealing with space economy, but also one think tank, the largest in Europe, called ESPI. Some of you may have heard about it. It's very close to here, which we are really sponsoring to a large extent. About 75 to 80% of the funding comes from us, but it is an independent organization, but they are working a lot with us. But our biggest establishments are in the Netherlands, in Noordwijk. There we have about 3,500 people, mostly engineers, technical people, where all the satellite projects are defined, developed with industry, tested. It's really the space heart of ESA in Noordwijk. We have headquarters in Paris. I'm now in Paris. I used to be in another center in Italy called Frascati, where we have what is called ESRIN, the Earth Observation Center, but there's also launches and a few other activities in ESRIN, about 1,000 people in ESRIN. I used to be the head of the establishment and the director of Earth Observation before. Then we have in Germany 2 centers. One is called the Astronaut Center in Cologne, and another one is the Space Operations Center in Darmstadt, where we connect with all the satellites in space. We steer them. We make sure that there's no collisions. We manage their instrumentation. Quite often we have to do some bug fixing, some problems that need to be solved, and this happens also in space, that we have to make some experiments, but then one of the instruments may not work as planned, and we have to sort it out, depending, of course, on what it is, in order to work on it. We have another center in the UK, and we have smaller ones in Belgium and a few other places. But as you see, we are quite distributed across Europe in order to really make sure that we have in different places, in different countries and different centers, our expertise. If you want to work for ESA, some of you are probably interested. Every job is published on the website, esa.int. And there's one category, just look for jobs, and there's always applications. At the moment, we are hiring about 300 to 400 people per year, because a lot of people are retiring, but also ESA as an organization is increasing. We are getting more funds, we are getting more activities, and of course we need people for that. And this is certainly something that is also of interest. We have a budget of about 7.7 billion this year. As I say, it keeps slightly increasing. And this is quite remarkable and quite nice, because budgets everywhere in Europe are stable or decreasing. So in space, which is very strategic and very also very interesting from an economic perspective, budgets are actually slightly increasing, not tremendously, but slightly increasing. But, and you will see in a slide later on, we are still underfunded, that's what I keep saying, compared to the United States, for example. So we need more funding for ESA and for space in Europe, and I will say a couple of words in a minute on what we do and how we do it. As you also see, we are spending about 60% of all space budgets, of all public space budgets in Europe, so we are by far the largest space organization. We are the space organization. The other 40% are spent by the European Commission, by EUMETSAT, some national agencies like the French or the Germans or the Italians have national space agencies, but also here in Austria there's there's the FFG, which is the Forschungsförderungsgesellschaft, which also spends funds nationally in space. So what is ESA doing, and what are our, I would say, our excellent work we're doing? Sometimes, and I'm quite often asked by journalists, what are you doing as ESA? Not everyone knows in detail what we're doing. And I say one simple sentence, I say ESA delivers success for Europe. And that's really what is my ambition, to deliver success for Europe. Meaning all the funds that I've shown before, this 7.7 billion, is actually converted into projects. We define programs and activities, and then we ask industry to bid and to develop it. I take an example, a rocket. We have launched Ariane 6 just recently. To build a rocket is not easy. It takes about 12 years. It costs about 4 billion. But what we do is, with the funding from the member states, we then issue a call for tender, and then industry applies across Europe. And this is exactly the way how we work, that we are in competition, inviting industry to support. Out of this funding, which you have seen before, this 7.7 billion, 15% stay in ESA for our facilities, our centers that we have, the test centers, the operations center, and so on. But 85% of the funding goes back to member states. That means goes back to industry in competition, and this is exactly how we work and what we do. And it works pretty well, because our space infrastructure is among the best in the world, and I really say this not because I'm the DG of ESA. It is true, and it is really quite remarkable. Let me show a few examples what we do and where we are really good. Autonomous access to space, rockets. Of course, if you want to use spacecraft, you need to have rockets, you need to fly to space. That means the satellites need to be brought to space, and obviously from there then the data are utilized for daily life. We have two rockets today, or rocket families I should say. Today, one is called Ariane 6, and the other one is called Vega C. Ariane 6 is the newest generation of the Ariane rocket. As you see, there is number 6, so we have developed different generations. The very first flight we had last year in July. It was a big milestone, as you can imagine. Now we had 4 flights already. 3 weeks ago we had the 4th flight, and we have another flight coming up in mid-December. So now we are ramping up the rocket, and means the space transportation with the big rocket, which is the same class as Falcon 9, which of course you all know from TV and news of SpaceX. Then we have a medium-sized rocket, which is the one on just next to it, which is called Vega C. So the big one, that means Ariane 6, is launching up to 20 tons to low Earth orbit, 20 tons. And the medium-sized one is launching 2.5 tons. So you see it's a factor of 10, almost less than the big one. But it's very versatile, and it's very important because it launches 2.5 tons is still a lot of weight for satellites. Satellites weigh somewhere between 500 kilos, 1 ton, 1.5 tons, sometimes 2 tons. So with the big rocket, you can either launch bigger satellites. We have also satellites that weigh 4 tons, or several small ones, depending, of course, on the configuration. So we have, with these two, we have our access to space guaranteed, and that is fundamental for any space power. We are developing a lot of technology, very low-level technology, as we call it, low technological readiness level, meaning that we are doing a lot of research, and we have an idea that this technology might work. Sometimes it takes 10 years, sometimes it takes 20 years to mature technology, and then it becomes operational or commercial. One good example of such a low-level, technical low-level technology is ion thrusters, and that's actually very close to Vienna. We have been investing for 20 years with the with the Fachhochschule Wien, in Wiener Neustadt, to develop this technology. This was in the 90s and 2000s, and many times we thought it doesn't work. It's just too complicated. We knew it should work, but we didn't make it to work. We didn't get it to work. That means our engineers, together with industry, and in this case, Wiener Neustadt. And at some point, we figured out how it works, and now it is a very commercial product, and it's a very successful commercial product. A company has been established out of it called Impulsion, and is now exporting this technology. It's an ion thruster that's a thruster on satellites that brings satellites into orbit and moves them in orbit to different places. Very successful and exporting a lot to the United States, also, of course, selling in Europe to ESA and other people. So we are developing technology from very low level to maturity, and then it can be used in operational or commercial domains. You see here, taking the pulses of our planet. That means we are having an Earth observation system called Copernicus that is the best in the world. And it really is the best in the world, because we have a number of satellites that measures all kind of parameters with all kind of sensors. Optical sensors, radar sensors, atmospheric chemistry sensors, so really measuring atmosphere, oceans, land surface, polar regions every single day, and understand how our planet functions. The interaction of the carbon cycle, of the water cycle, of the various Earth system as we describe it, and in order to really understand how it works. Why do we need to do that? To understand climate change, to monitor our planet for environmental monitoring, but also for agriculture, for forestry, for pollution monitoring, for ship routing, for iceberg monitoring, for many things, including disaster management and other domains. So it's really a system of a number of satellites that we have built up that is quite versatile, and it is literally the best in the world. Nobody else has something comparable. Neither NASA or the United States, nor China, nor India, or Japan. Really, this is something where Europe has built up a very, very good capacity. About 1/3 of my budget of ESA is going to Earth observation, and Earth observation is a strength of Europe. And we disseminate, as you see, 350 terabytes of data every single day across the world for free. For free means if you want to have an image of your house or your holiday destination, you log in, you have to register once, and then you can get images every day or whenever you want to have an update of this area. You just look for it, call Copernicus Sentinel Free Data ESA, and then you will find a link and you can get there. Galileo, we are also good in navigation. Let me take another example where Europe really has achieved something remarkable. All of you know GPS, or you have heard about GPS, which is in operation since the 80s, and it's the American Department of Defense navigation system, as you know. It's used since many decades. In the 90s, Europe said, look, this is such an important technology, we cannot just depend on one country, that means the United States, for this technology. There was the war in ex-Yugoslavia, there was the war in Iraq, and people realized that you need precision navigation for whatever you do, for security, but also for other purposes. During the war in Iraq, the GPS signal was jammed. That means your car or your airplane was getting a wrong signal or a jammed signal and didn't really work. So Europe said, this cannot be. We need our own independent system. Decided to develop Galileo, and Galileo today delivers the most accurate navigation position in the world. Better than GPS. Better than GPS. And I think this is something where we can be very proud. We had a 15 years delay compared to the GPS system. But now, after 30 years of development, because now Galileo is 30 years old, we have the best navigation system in the world. And we keep improving it with the next generation of navigation satellites. Meteorology weather satellites, we are having them since the 70s, late 70s. Meteosat probably is known to you, which is the geostationary satellite, but also polar orbiting satellites taking measurements of our weather, climate, but all our atmospheric parameters, but also surface and ocean. It is fair to say that the weather forecast would be very bad if we would not use satellites or have satellites. And with satellite, about 80% of our data for daily weather forecast or next week's weather forecast come from space. So if we would switch off the satellites, the weather forecast would be bad, because you would basically say tomorrow is the same weather as today, which sometimes is true, but in most cases it's not. So in other words, we need this technology every single day in our life. Weather forecasting, for banking, for telecommunications, for navigation, and this is what we develop as ESA, this basic technology that is required in your daily life. And of course, we also work on the dreams, on exploring the universe. So you see here an example of the James Webb Space Telescope, where very few people know it's a mission led by NASA, which is true. But out of 4 instruments, 1.5 have been provided by ESA. And the mission was launched on Christmas Day 23 by ESA from French Guiana on Ariane 5. Very precise, because our Ariane rockets are known to be very precise. The insertion to the orbit was so accurate that the James Webb Space Telescope had an estimated lifetime of 10 years, or was designed for 10 years lifetime. But thanks to the very accurate insertion, it will live now more than 20 years, because it doesn't need a lot of fuel to correct and to get there. So we have really inserted it on the right spot, and now it goes. It is measuring since some time already and providing stunning images every single day. The global context is shifting enormously everywhere, but also in space. Geopolitics, of course, I don't need to explain. We have a war in Ukraine. Russia was invading European territory. We have the United States who are shaking up geopolitics and tell Europeans to invest more in defense, be more autonomous, and we have tariffs. We have a geopolitical environment that is quite shaky and has really changed a lot in the last few months or very few years. Also in space, NASA as a partner is not as the NASA we used to know from the past. Why? Because the budget of the United States has been proposing, it's not yet decided, but proposing to reduce the NASA budget significantly, especially in science. And this is something where we are strong. So my point is, we have to make sure, as ESA, as Europe, that we have what we need in terms of autonomy, that we are stronger, more autonomous or less dependent in our space technology. Today, the cooperation we have with NASA, I would say, thank God, is only about 5% of my budget. 95% of my budget is not depending on projects with NASA, but these 5% are very strategic and very visible. Because with these 5%, we are bringing astronauts to space, to the space station, only with NASA and Elon Musk. We are going together to explore the moon. We are participating in the Artemis program. We are having joint projects on Mars. But as I say, today, this is about 5% of the budget, and in the future, probably even less. But what I also do is I'm strengthening cooperation with other countries. I've just signed an agreement a year ago with Japan for a reinforced new cooperation with India, with the United Arab Emirates, with South Korea. Already Canada is participating in our programs, and Australia, just a few weeks ago, has decided at government level to negotiate a new agreement with ESA, a bit similar to probably the one we have with Canada, to have a new cooperation framework where Australia might actually participate much more in the future with ESA than they have done in the past. And we are a respected partner. People like to work with us because, number one, we are good. We are excellent in terms of technology. We are smaller, but we are good. We are reliable because we do deliver what we promise, and we have never failed to deliver. Sometimes it's tough. Sometimes it's difficult because we have technical problems. Space is always on the edge of the unknown and on what is almost impossible to do, but we do explore these frontiers, but we deliver. And this is something that people respect, and that's why they want to reinforce cooperation with us. And I think this is nice to see for me as the head of ESA, but it's nice for Europe altogether that Europe is respected as a partner and is a good partner worldwide on space technologies. Economically, also space is changing fast. Space is one of the fastest growing segments of the economy, of economies worldwide. Globally, we have an increase of space business, or the space economy, as we call it, by about 10% per year. 10% per year is huge. 30% in 3 years if you want. There are very few sectors in the world or in the economy that grow at this speed. Transport, energy, or housing are not growing that fast, if they grow at all. Some of them are stable or even decrease. The economies of Austria, of many countries in Europe are growing at 1%, maybe 0.5%, maybe 1.5% or 1.3%, but the space sector grows by 10% per year since the last 10 years, and it keeps growing at the same rate, actually even a bit faster in the future. And that's great. From a purely economic perspective, space is a future domain of good growth. Space is also, and I keep saying this again and again, is used in everyday life. It's strategic. If you do not invest in space technology, you are out of business or out of future innovation pretty soon, because space is used for weather forecasting, for navigation, for telecommunication, for security, for defense, and many other aspects. So space is strategic, and you do need space technology every single day, already today, and in 10 years from today, even more, because it is much faster, much further integrated into daily life. And we have new partners coming to life. You see here a rocket you have probably seen this in the news. This is Starship. When it was the first time landing again on this mechazilla, which is this arm that catches the first stage. Quite impressive. It was a bit wobbly, and you see there's flames and fires on it, but it worked. This is Elon Musk pushing the edges of technology, but changing the space sector radically, especially on rockets and Starlink, that means on telecommunication. And that's pushing us. It also shows that space is very attractive, that there are people investing in it, that people are, billionaires are putting money into it and having their space programs. Their rockets, because rockets are probably the most visible and the coolest thing to invest in, but space is very wide, has many dimensions, and this is something that is really growing, and also showing that private money comes into space. Venture capital companies, banks, private investors are putting more and more private money into space, which is great to us, because there we get more, I would say, additional funding based on the framework that we are creating. So we have developed a strategy of how to grow. But let me give you first some bad news, but there's also some hope at the end of the tunnel in order to make it not so bad. This figure here shows the global distribution of public funding in space. And you see, the United States today is spending about 60%, to be very accurate, 61% of global space funding. It's great. If you are an American and if your name is Elon Musk, that's great, because there's lots of opportunities in order to really catch some of this funding and then create some activities. Europe is at 10% today. That's not good, but we are about to change it. How do we change it? ESA is having a ministerial conference, actually in 10 days from today, so I'm pretty busy these days, as you can imagine, putting the last stitches together of our ministerial package. ESA is working on it. Just a month ago, Germany was announcing to put 35 billion, not million, billion of budget into space and defense, or space for defense. The European Commission is preparing its next multi-annual financial framework with about roughly 50 to 60 billion funding for space for the 7 years from 28 to 35. So you see the call for increasing funding for space in Europe is working, and we are increasing in the years to come through ESA, through the European Commission, or nationally. And that's good news, because that means that we finally raise our stake to a level which is much more appropriate to our share and our strength of our economy. So now let me show in a few examples what we do. So this is what we put together. We call it the ministerial conference package. It's 22.25 billion, which is my proposal to my member states. We're having this conference every 3 years. I will not get 22 billion. So when you read the figure, don't be disappointed if the result is not 22 billion, because it never happens. Actually, people say if the Director General would propose exactly the amount that we have money for, then it was a bad proposal. You have to have more proposals, more options, because we have a system in ESA where member states can put as much money as they like. It sounds very strange that you would voluntarily fund programs where you don't have to, but this is the way it is. 80% of my budget is optional programs. That means member states can subscribe 0, or a lot, or a big lot, or a small lot. And this is, of course, great, but that means that we have to be attractive in our proposals, our satellites. We have to be competitive, we have to be good, and that's why member states subscribe. But also, we have a secret golden rule that if you give me 100, I promise you to give you 85 back, because 15 are used for my agency, for the centers, for the operation center, and so on. But the 85 I give back to industry, but also to the country where it comes from. So that means by subscribing to ESA, people are building up industrial capacity and strength in their country. And this is, of course, very, very attractive. So this is what we are looking at our ministerial package called CM 25, that means Council at Ministerial Level 2025. It takes place in Bremen, in northern Germany. Germany is hosting at ministerial level at the moment the ESA chairmanship, or is the presidency. It rotates. Afterwards will be somebody else. So we are in 10 days in Bremen. Look at the news, but it will be, I hope, good news coming out from there. And we organize our proposal along the 5 goals of ESA Strategy 2040, a strategy which we have published this year. Goal number 1 in this strategy is protecting our planet and climate. The name already indicates what we are doing. Let me show a few examples of what the proposals are that are on the table. Copernicus, I mentioned the program that is the world's best Earth observation program, where we deliver 350 terabytes of data to the world every day for free. We're developing and further developing this program with new satellites and new capabilities. So this is certainly a highlight and one of the important ones. Biomass, we have just launched a satellite using a P-band radar, penetrating into the vegetation canopy, through the canopy of a forest, of a tropical forest, and looking at biomass. That means the size of the stems in tropical forests in particular. Interestingly, the same P-band radar, which is a long wavelength, goes into sand of very dry areas. And we have seen images of deserts where we go 8 meters deep, and we can see the structure underneath, which is covered by sand, because it penetrates into dry sand. Then we have a number of Earth observation missions called Harmony, Wyvern, Scouts missions, that means bigger and smaller ones. But also, when we protect our planet, it's not only for climate change studies, but also literally our planet. We have one mission called Ramses that will look at an asteroid that will come to Earth. It's not hitting us, but it comes very close, within the 35,800 kilometer arc of the geostationary satellite. So it comes in the order of 35,000 something meters, or 35,000 kilometers, sorry. It comes pretty close to Earth. It will be visible with your naked eye. It flies over Europe and Africa, and it comes on, listen, Friday the 13th of April 2029. So it is coming in a couple of years, so not tomorrow, but it is a Friday the 13th, and it will fly by, but we build a satellite to fly there, to observe it, and see how the mission, how the asteroid will interact while it comes to Earth. We're not destroying it, so no worries. There will be no explosion, but we really monitor how this interaction is. What is the impact of the gravitational aspect itself? Even on what's the impact of our tides on the asteroid itself. So there will be a lot of measurements we are looking at, but also, of course, to understand how the asteroid is made of, just in case that another one comes of a similar size and direction and would eventually hit planet Earth. Of course, this we would need to avoid, but therefore we need to understand how they are made of, what their composition is, and could we or could we not do something in order to have an impact that doesn't hit planet Earth, just in case. So there are interesting missions we are having on our proposal. Another one is Vigil. Vigil is quite interesting because it measures the strength of solar storms. As you know, the sun is not quiet, it's very active. It's a nuclear power plant, if I may call it this way. Very active with solar flares, and these solar flares come in all directions, but also to our planet Earth. And if there's a strong solar eruption, it might actually impact our electrical grid on the surface or the electronics in space of our satellites. So we need to know early enough in order to protect our satellites, switch them off, or protect them, or also on ground protect our electrical grids or whatever infrastructure we have. So we build a mission called Vigil, which is telling us early before such a solar storm is coming in order to avoid damage. Number 2, explore and discover. As the name indicates, we have missions that are looking into exploration and discovery. What you see here is a number of missions that are either coming or already in the development of exploring the universe. And these are the big questions of the universe. Where do we come from? Where do we go? Is there life out there? Is there other forms of life somewhere outside planet Earth? Imagine there is life. Imagine, and there's one of the missions we are studying right now, that would send a probe to an icy moon of Saturn called Enceladus. And if we land there, and we just imagine we discover forms of life. Could be primitive life, could be more intelligent life, but if you would analyze, and we will analyze, it's still very far away, so probably some of you will become project manager of such a project, because it takes 10 years to fly there, and more than 10 years to build such a mission. So you see, we are talking of the 50s, and not tomorrow. But just imagine we discover some traces of life. Would that life have a DNA or no DNA? If it has a DNA type of structure, is it similar to ours? Just imagine. If it would have a DNA, that means there's one source somewhere out there, and we are one variant of some life somewhere else. If there's no DNA or no structure like a DNA, that means different forms of life can develop in different places. So very philosophical, very religious, very important questions that we are looking at. We do not yet have the answers, but at least we are looking for evidence and information of this kind of thing. We have another mission coming afterwards called Rosalind Franklin. We will be the first ones as ESA to fly to Mars. And you all hear that Elon Musk wants to fly to Mars for exploration. We will fly there before. We launch the mission in 28. We will have a drill that goes into the surface of Mars and looks for traces of life again. So we know there's no life on the surface because we would have seen it. But if there is life on Mars, or ever has been life on Mars, people say, these are exobiologists, it has to be under the surface, because on the surface itself, it will be killed by cosmic radiation. There's no atmosphere, or very tiny atmosphere. It would not survive. But if there's any life, it could be underground. Maybe there's no life. It's probably more likely. But there could be life. Again, we're having a drill. We go 2 meters deep, and we analyze on the Mars surface whether there might be life or not. And this is something quite interesting, as you can imagine, to, again, search for life out there. So this is also what we are doing. We're not only looking at our planet Earth for climate and for agriculture, we also do the very exotic things that are actually quite amazing. You see some of these missions. JUICE actually is one of these missions to an icy moon much closer on Jupiter. There are 3 icy moons we are looking at. Again, same philosophy. is there a possibility of life in these icy moons? And some of these icy moons have more water than we have water on planet Earth. It's underground, under a thick cover of ice. And again, as we know also on planet Earth, there's life in planet Earth in the deep ocean, which doesn't need oxygen, doesn't need light. It exists. It's a very primitive form of life, but it exists. Maybe there's something similar out there. Again, we are searching for it and we are looking at it. This is the rover I mentioned before with the drill, called Rosalind Franklin. It's in development right now and is to be launched in 28. Actually, this rover has a little bit of a sad history. And if I say sad, I'll tell you why. We started the project around 2010, and we started the project with NASA, with the United States. 2 years later, 2012, NASA canceled their participation. They said, look, we don't have the funding. We cannot participate in this project. So they left us alone. So we said, look, what do we do now? It's a huge mission. We need technologies that we don't have today. Whom do we ask? And we asked at that time, this is 2012, we asked Russia to work together with us. And actually Russia, Roscosmos, did work with us, and we built a joint mission, ExoMars, for 10 years. The mission, this rover, was ready to fly in September 2022. But you know what happened in February 2022. Russia invaded Ukraine, and I had to stop all the cooperation we had with Russia. That means we have invested 10 years of time, about 1 billion of budget. Russia has done the same, invested 10 years of time and about the same budget. We were ready to fly, and I had to stop it for very obvious reasons. So now we were again left alone. NASA dropped us. I had to drop Russia. So what do we do? So we had, this was really quite an action in 22. I just became Director General of ESA, so this was one of my big challenges I had on my table. So what I did is we redesigned the mission, and we did everything European, which was done by Russia, with 3 small exceptions. The radioisotope heater unit, which is a radioactive device to keep the rover alive at night, to heat the rover so that it survives the Martian night. We don't have the technology, so we asked NASA to provide it, and they said yes. In order to launch a radioactive device, you need a launcher that is capable of doing it. Again, this would be needed from the United States. Again, they said yes, they can do that. And there's another element we don't have in Europe yet. We call it braking engine. That's the engine that lands the rover safely so it doesn't collapse, so it doesn't jump, or it doesn't fall on the surface of Mars. So these 3 elements NASA was offering, or was providing, or is providing. So this is a cooperation that went from an American corporation, American ESA corporation, to a Russian ESA corporation, to a European mission with 3 small contributions from the US. So this is now being developed, fingers crossed, but we are on track to launch it in 2028. It takes about a year to get there, but as of the end of the century, you will see first information coming from that rover. In the middle, we developed what we call Argonaut, a mission that is transporting 1.5 tons of experiments, of equipment from Earth to the moon, because we expect that the moon will develop into an economy. There will be business made, there will be services offered, somebody will dig into the moon surface and extract resources, rare earths or rare moon minerals, oxygen will be retrieved from water. There's water on the moon surface, as you know, on the South Pole. We will probably use 3D printers to convert regolith, which is this rock on the moon, into structures. So there's a lot of economy developing, and this is one of the rovers that will bring equipment and facilities up to the moon surface in order to work there. On the left-hand side, you see a capsule which we are developing right now to transport cargo to the space station. Today, we do not have this technology. First of all, to go up to the space station will be about 4 tons of cargo to bring up, to dock on the space station, unload, and then come back again with some 1.5 tons of cargo and land on the surface. And that's tricky. As you can imagine, you see fire here on this capsule because the re-entry technology is something very delicate, and that's the dangerous part, which of course we test. So we are developing this now for cargo. Hopefully, someday, we can put astronauts in there, because 4 tons up is less than the weight of an astronaut, or 2 or 3. So this is something, certainly a precursor or a module that could be utilized in the future in a further evolution with a new decision to eventually also fly astronauts up to a space station. European resilience and strength. I talked about rockets already. I don't need to repeat. These are the Ariane 6 models with 2 boosters and 4 boosters and Vega C. But also at the same time, we have launched, just like NASA did, and again, Europe is probably 10 years later, but eventually we will succeed, like in Galileo, like in Copernicus. We do the same as NASA was doing, that we as ESA will be an anchor customer to companies, rocket companies, who want to sell rockets to us. So we let industry do whatever they want, their technology, with their partners, in whatever place they want to develop it, whatever place they want to launch, and we buy launch capacity, that means launch services. NASA has done the same, and they have also offered to industry to develop rockets and launchers. They have done that, and out of it, SpaceX was emerging with Falcon 9 as the rocket. So these are the new ones. They're not flying yet, but they will come. One of them I expect to fly before the end of the year, another one next year, maybe 2 next year. So they're all coming one after the other, and we put them in competition, and the best ones should win. European strength and autonomy. On the left-hand side, you see actually the equivalent to Starlink, again, a bit later, but Europe is developing something called IRIS². It's a system which is offering broadband internet connection from space, from satellites. And as I said, this is really the European version of Starlink. We call it IRIS², should be ready by 2030. Earth observation, again, and also PNT is navigation. We developed the next generation European autonomous systems. And here's one element that we are proposing, which is, and this has a connotation for security and defense. Europe today is relying on other, or is to a large extent, relying on the United States for intelligence, surveillance, and reconnaissance. That is really military applications to know what happens everywhere in the world. With very high resolution sensors, 20 centimeters roughly, radar and optical, globally available. America has it. We don't have yet. We have a few satellites that can do similar things, but it's a handful or maybe 2 handfuls of satellites, but not a full constellation. And this is what I'm proposing, to build up a constellation, first based on existing capabilities of Germany, France, Italy, but then complemented with European capabilities and new technologies. And this is day 1 of a new initiative, a new flagship for Europe. It's probably day 1 comparable of Copernicus. It will take time to build it up, but certainly something that Europe needs. Small difference is that today time is much more pressing, and we have to go very fast, given the geopolitical situation and the need for such a system very quickly. Boost European growth and competitiveness. So this is really the commercial angle of it. So what you see here are some figures of how many projects and how many business incubation centers we have, and how do we attract private money and help private companies to succeed. We have the largest business incubation network in Europe. It is now 20 years old. You see some of the figures here of how many companies, how much money flow in. Just last year, we got 1.5 billion of private funding into Europe, private funding complementing the public funding of space in order to really help companies to attract money, venture capital companies or other banks or other companies. And you see this is something that is a huge network, because Austria is quite well represented. There's a PhilLab, a business incubation center. There are quite a lot of activities and something that really goes very well. I understand somebody of you is actually working on one of those. boost European growth and competitiveness. Again, these are programs to develop technology. These are basic technologies which we are testing on so-called IOV, IOD satellites. That means we are testing a new technology, we fly it, and then if it works, companies, private companies can then make a constellation, can make a new satellite in order to really make sure that this is tested and this is properly continued. And last but not least, inspire Europe. I've just met somebody who has done a zero-gravity flight. Space is also about inspiration. We have astronauts, we have zero-gravity flights, we have education centers, we have international cooperation. So we do also inspire young kids, older kids, myself still very inspired every single day of what we do in order to make sure that space also is something that brings people to study STEM, to get engaged in technology studies, to get engaged in using this technology in daily life. And with this inspiration, I would like to thank you for your attention.